Hello students, in this video we are going to discuss about the equilibrium constant from the Nernst equation. If the circuit in the Daniell cell is closed, then we note that the reaction takes place, that is zinc plus copper ion is giving rise to zinc ion plus copper. When this reaction takes place and as the time passes, the concentration of zinc ions keeps on increasing while the concentration of copper ion, that is, keeps on decreasing. So as the reaction passed, we can find that the concentration of zinc ion increases, but the concentration of copper ion, that is in the reactant here, it keeps on decreasing. At the same time, the voltage of the cell as read on the voltmeter keeps on decreasing. After some time, we shall note that there is no change in the concentration of copper ion and as well as there is no change in the concentration of zinc ion. And at the same temperature, the voltmeter reading shows 0. This indicates that the equilibrium has been attained. So what we can say that at this stage, the equilibrium stage is attained. That is why there is no change in the concentration of zinc ion and there is no change in the concentration of copper ion and the reading in the voltmeter is 0. This indicates that the equilibrium, that is the equilibrium stage is attained. So in this equation, the Nernst equation can be represented as that we have to discuss here, as we have already written the Nernst equation for this equation, that is the Zn plus Cu2 plus giving rise to Zn2 plus Cu. This is the Nernst equation which we have learnt. So at the equilibrium stage, we can say that the voltmeter reading is 0. So at the time what we can say, E cell is equal to 0. So when E cell is equal to 0, now the above equation can be written in this way, that is 0 is equal to E naught cell minus 0.059 by N log of concentration of zinc ion by concentration of copper ion. Now here we can rearrange this equation. Now we got the equation, that is E naught cell is equal to 0.059 by N log of concentration of zinc ion by copper ion. Now this is the equation, that is the equation of this Daniell cell at the equilibrium stage, because here E cell is equal to 0. That is why, because the reading in the voltmeter is shown as 0 here, that is E cell is equal to 0. So we got the equation, that is E naught cell is equal to 0.059 by N log of concentration of zinc ion by copper ion. As we have learnt in the 11th standard, the concentration of the product by reactant, that is at the equilibrium stage, the value is a constant value that is called as equilibrium constant. So this is what we have already learnt in the 11th standard. So concentration of product by concentration reactant and the stoichiometric coefficient on the powers, the ratio is equal to a constant, that is equilibrium constant. Now here in this equation, that is the concentration of zinc ion by concentration of copper ion. Now we can write this equation in this way. Now we can get the equation here, that is the relation of E naught cell with the equilibrium constant. So this equation here, that is showing a relation between the E naught cell and the equilibrium constant. So this is what the equation which you have to learn for doing the problem, because the problems will be getting on basis on this equation. That is what, note the equation, that is E naught cell is equal to 0.059 by N log Kc, and where the Kc is the concentration of product with their powers, stoichiometric coefficient and the powers by concentration of reactant. Now let us do a problem based on this concept. Example 3.2, that is a text solved problem. Calculate the equilibrium constant of the reaction. The reaction is given here, that is a copper plus twice Ag plus is giving rise to copper ion plus twice Ag. So here it's a redox reaction. Better to split the reaction as anode and cathode reaction. So you can find that the 2 electron is lost by the copper and the 2 electron is gained by the 2 silver ion. So here the number of electron lost is equal to 2 here, because what we have the formula here, that is E naught cell is equal to, the formula is E naught cell is equal to 0.059 by n log Kc. What is the value of n here? That is here it is 2. Now we'll be applying the value here. The value of n is equal to 2. So that is written here, the value of n is equal to 2 log Kc. Now the question is to calculate equilibrium constant. That means Kc we have to find out. E naught cell value is given to us. So we'll be substituting the E naught cell value. So we'll be finding out the log Kc from this, and after getting log Kc value, that is 15.6, we will be finding K value, that is Kc value, by taking the anti-log of this value, that is 15.6. So we get the value, that is 3.92 into 10 to the power 15. So this is very quite important type of question. Usually these type of questions will be there in the exam. So the similar type of questions you practice well. So for this, what you need to learn the formula? We have to learn the formula. So all of you note it down, the formula. That is this formula. The formula is, that is the formula E naught cell is equal to 0.059 by n log Kc. That is only we have to apply this formula at the equilibrium condition. So all of you look at this problem carefully and do it in the notebook, and the similar type of questions also do it in the notebook. So this is all about this video. Have a nice day.